Hi, I'm Kendall Noto, and I will be presenting homework number 6, which is about the abacus tutorials of Chapter 6 and Chapter 7, going through the tutorials and reading those chapters, and then doing the examples that are at the end of those. So the first, Chapter 6, we were just asked to make the cargo crane. And then here's the final sketch of that crane, just the side view of it. And then here is the full truss, which has all the cross braces on it, as well as both sides of the truss, as well as the tip load is added, and then we will just have to run the job to see the deformation of that tip load that was added. And then here as well, I just included the hard copy of the truss, which is just the full geometries of the cross braces that we added. So this is essentially what it could look like in real life. And then here is figure 6-25, which is the undeformed truss superimposed on the deformed truss with the tip load included on it after we ran the job. So this is the result from that job. And you can see that the tip load just kind of made the front of the truss deform down. As you can see, it's red at the tip, so that's where the most load is being applied. And then here's figure 6-28. This shows the bending moment of the deformed truss. So the blue is showing the minimum bending moment, which is negative 182 Newton meters, and then the maximum is the red, which is 256 Newton meters. And then here we move on to Chapter 7, which is using the truss that was used in Chapter 6, which we just changed this one. Instead of a static load, we make a dynamic load. And then this one is figure 7-8, which is the deformed truss with the dynamic load on it. So this is mode 1 out of the 30 modes, the deformed truss. And then here is mode 3. So out of the 30 modes, we're just showing 1 and 3. This is figure 7-9. And then here is the figure 7-10, the plot of all those 30 modes that were simulated, and this is the force by time. So at time 0.235, the dynamic force is negative 3.992 Newton meters. That's negative 3.992 times 10 to the 4. And then for question 3 of the homework, we were asked to find real-world problems that follow the linearity requirements for the transient modal dynamics. And I found that a reaction wheel that's used for attitude control and stability on a spacecraft, as well as any 4-stroke engine, these follow the requirements for linearity because they both follow the same path. All the time, the wheel always follows in a circle, as well as the 4-stroke engine is always following that same path. So the graph of that force versus time will always be in a linear direction, and there's no non-linear geometric effects to those. So this was my homework 6 participation video. Thank you for watching.